Welcome to Yengel's algorithm series for absolute beginners. In this video, we'll try our best to understand insertion sort algorithm. First, we'll take a look at the logic that's governing insertion sort, and then we'll dive into the code. If we have to write a program that acts on an input list containing numbers in random order and sorts them in either ascending or in descending order, then insertion sort algorithm is a technique which we can employ to accomplish this task. The core of insertion sort algorithm is it compares two values and it switches their places if necessary. Let's check our engine in action using a sample input. Our sample input is a list containing numbers in random order. We create a sublist that accepts values from the input list. It is on this sublist our engine performs the compare and switch operation. The first value from our input list is inserted into our sublist. The engine then acts on this sublist. At this point, our sublist has only one value. We cannot perform any compare or switch operation on this. We insert the second value from our input list into our sublist. The engine now acts on this sublist and determines where this newly added item must be placed within the sublist. Since we are aiming to sort the input list in ascending order, the lowest value must be placed on the left-hand side and the highest value on the right-hand side. The engine then performs a comparison operation using a greater than symbol because we are aiming for an ascending sort, and it switches their places if necessary. It then pastes them back into our sublist. After the first pass, we have a small section of our input list sorted. If you remember, first we had a sublist with just the first value. The second value was then inserted into our sublist and it was switched to its rightful spot by our engine. From this we can understand that during the first pass, we have taken a small section of our input list and we have sorted it in ascending order. We still have some unsorted value in our input list. Let's fix that. We insert the third value from our input list into our sublist. Our engine then performs a compare and switch operation on this sublist. In this case, it seems we don't have to switch their position, so we paste them back. The next pair of value is already sorted, so we move on to the next step. Let's do a small analysis here. We inserted the third value from our input list into our previously sorted sublist. The engine then tried to find its rightful spot within the list. The number was then moved to its rightful spot within the sublist. We still have some unsorted number in our input list. Let's fix that. We insert the last and final value from our input list into our sublist. The engine then acts on this sublist to find the rightful spot of this newly inserted number. It then performs a compare and switch operation on all the pairs of numbers until the newly inserted number has been moved to its rightful spot. It seems we have performed the same action all over again. We inserted a number into our sorted sublist. We then try to find its rightful spot within the list, after which it was moved to its rightful spot. There we have it. Our input array has finally been sorted. Now let's see if we can understand the implementation of this algorithm. If we were to feed our sample Python code here with an input list, the first thing it does is it calculates the length of our input list as highlighted above. Using this value, it constructs a list in its memory with values ranging from 1 till length minus 1. There's a brilliant reason behind constructing such a list. We'll understand the reasoning pretty soon. Since the length of our sample input is 4, the list which our program has to construct translates to the following values. We then loop through each and every value of this constructed list. And for every iteration, we execute the code block that exists within this for loop. For every value in this constructed list, our program creates a new list with values ranging from the number themselves till 1. We then loop through each and every item in this newly constructed list. This has created a nested loop And for every iteration, we execute the inner code block that lies within this for loop. For every value in this newly constructed list, we perform a compare and switch operation on values located at the specified index. After all the iterations have been executed, we would have a sorted list. Let's do a dry run. From the length of our input list, we construct a new list. Do remember that all the operation which we are going to perform will be done on the input list. During the first iteration of our outer loop, we construct a new list. This new list contains values representing the index of our input list. Then for each value in this highlighted array, we perform a compare and switch operation. We compare neighboring values as shown in the code above. We have completed the first iteration, and it seems we have sorted a small sublist of our input list. We still have some unsorted items in our input list. Let's see how our program fixes that. We move on to the second iteration. A new list is constructed from this value. The newly constructed list has two index values. One of the value points to our previously sorted sublist. The new value in the highlighted list points to a number that is yet to be sorted. If we were to loop through all the values of the highlighted list, then we would have worked on this small subset of our input list. The highlighted section contains a sorted sublist from our previous pass and a new number that is yet to be sorted. Let's see what happens during each iteration. For every index value in the highlighted list, we perform a compare and switch operation. We have moved the new number into its rightful spot within the sublist. After our second pass, we have successfully got our newly sorted sublist. Well, it seems our input list has one value that is yet to be sorted. Let's see how our third and final pass will brilliantly resolve this situation in no time. We fetch the final value and we construct a new list in the program's memory. Do you remember, during our second pass, we performed operation on values at both these index. The result was we constructed a new sublist with values sorted inside them. During this third iteration, we have got the same index value along with a new one, which points to the value that has not been sorted yet. So during this third pass, we are inserting our unsorted number into our previously sorted sublist, and we try to find its rightful spot within the sublist. And now, for each iteration, we perform a compare and switch operation with the neighboring value. As we can clearly visualize, we are moving the newly inserted unsorted number among our sorted sublist to find its rightful spot. After the completion of all the iteration, we have successfully sorted our input list. This concludes our video explaining the brilliance of insertion sort. See you guys in the next one. If you guys like our work, consider subscribing to our YouTube channel for more educational content.